Hi, nice to meet you. Welcome to our open campus at Hiroshima University. I'm Koichi Kato, one of the academic staff at the School of Dentistry, Hiroshima University. Here I teach fundamental aspects of dental materials to the students who are willing to be dentists, oral hygienists, or dental technicians. I'm really happy to have a chance today to demonstrate how we teach dentistry at our school. So what is special, what is unique in our dental education is that, all the lectures and the practices are given in both English and Japanese. In addition, in a class, there are a lot of international students, especially from Southeast Asian countries. They study dentistry together with Japanese students, so we have a quite diverse environment. Now I would like to show you a little bit of an example of my case. Actually, I have a class for dental materials. Maybe you know that various artificial materials are used in dental treatments, such as metals, ceramics, and organic polymers. In this video, I'm going to show you the part of my lecture on polymeric dental materials, especially on the chemistry of polymer synthesis. Okay, here we go.
The topic here is organic polymers. First of all, as an introduction, I want to give you a brief image of polymers and to remind you how polymers are overflowing in our life. You can find polymers everywhere. For instance, your clothes are mostly made of polymers. Probably you are now using PC on a wooden table. Wood is also polymers. Foods, daily commodities, and even medical and dental devices are often made of polymers. Our body is composed of a lot of polymers, such as proteins, polysaccharides, or even new coronavirus is made of polymers such as RNA and proteins. So polymers are everywhere in our life. By the way, polymers can be classified into two types, depending on how they are made. The first type is called synthetic polymers, such as polyethylene, polystyrene, polyester, and so on. They are artificially made from petroleum by chemical reactions at factories. The other type is called natural polymers, such as proteins, polysaccharides, and nucleic acid, DNA and RNA. They are formed in organisms. At the bottom of the slide, I just show you the examples of polymeric materials. Probably you use PET bottle every day. PET is an abbreviation of the chemical name polyethylene terephthalate, but not from a pet like dog or cat. Be careful. In the previous slide, I showed you there are many types of polymers. Now we consider how we can define polymers, namely organic polymers. Organic polymers are compounds of large molecular weight, formed through repeated chemical reactions by which monomers are covalently connected to each other. For example, so look at upper right. You can see a chemical structure of ethylene which has CC double bond. This bond is easily cleaved and attack neighboring ethylene to link each other. This is an example of a monomer. So mono means one. When two ethylene monomers bind each other, then we obtain a dimer. And then we got a trimer from three of them. After repeated reactions, a long chain of a large molecular weight is formed. That is a polymer. In this case, poly means many. In general, polymers have molecular weight more than 10,000, though there is no clear criteria for polymers regarding their molecular weights. In the case of ethylene, molecular weight of the monomer is 28 grams per mole. When more than 350 ethylene monomers react each other, then we got the polymeric form of the ethylene with molecular weight more than 10,000. This is called polyethylene. As you see in the bottom table, if chains have intermediate molecular weight ranging from 1,000 to 10,000, then we call such substances oligomer. Well, now we look into chemical reactions, how polymers are synthesized, especially in the case of synthetic polymers. Basically, there are two different pathways for the formation of polymers. One is called stepwise polymerization, and the other is chain reaction. So I will explain chain reaction in the next slide. Here is about what is stepwise polymerization. So first, look at the example of the reaction. That is the case for polyethylene terephthalate. So please look at the bottom. In this case, we use two different monomers. Terephthalic acid that contains two carboxylic acids in a single molecule. And the other is ethylene glycol, which contains two hydroxyl groups in the molecule. When we remove water molecule from these two molecules, then we get an ester linkage, ester compound. Such reaction is called condensation reaction. And if such reaction repeatedly occurs at the other ends, finally we get the polymer form, polyethylene terephthalate, PET. As in this case, monomers react one by one at the growing end and finally form a long polymer chain. So that is why molecular weight increases with the conversion. The more important for dentists is here. That is chain reaction, namely a radical polymerization. That is one type of chain reactions. You, dentists, need to do this reaction by yourself during dental treatments, even in the oral cavity of the patients. So let's look into details. In contrast to the case of the stepwise reaction, the chain reaction takes place very quickly at once to form a long chain. Therefore, the number of polymer chains, the molecular weight, increases with conversion. Again, radical polymerization is one of the most important polymerization reactions for dentists. Because, for example, polymethylmethacrylate, this is the main component of denture, this polymer is synthesized by this reaction mode. We mostly use monomers that contain C-C double bond. The reaction is initiated by radicals generated on the initiator. So I will explain what is radical in the next slide. Once initiated, the reaction takes place very quickly through 4 elementary reactions: initiation, propagation, recombination, and disproportionation. Here I show you what is radical. Consider here a C-C covalent bond. In the covalent bond, 2 electrons occupy an orbital to stabilize a pair of atoms C and C. When we apply heat or light energy to the electrons, then the covalent bond may be evenly cleaved to yield unpaired electrons. Molecules that have an unpaired valence electron are referred to as radicals. Such an atom with a radical is chemically quite reactive and immediately undergo redox reactions with other molecules. This is radical. Now I'm going to explain the details about the 4 elementary reactions, how they occur. For easy understanding, so please imagine a reaction mixture shown here that contains a monomer, initiator, and solvent. So we start radical polymerization reaction in such a system, okay? The first reaction is named initiation reaction. So this is to generate radicals within a reaction mixture. One of the most typical initiators is benzoyl peroxide, shown here, which has a COOC linkage. This is chemically quite unstable, and that is why we can easily cleave this linkage by heat or light energy or by redox reaction. By cleavage or homolysis, benzoyl peroxide is converted into 2 molecules with O radical or 2 molecules with C radicals. This reaction is called initiation reaction. As shown in the table, there are 3 different types of initiation reactions. First one utilizes light energy to activate camphor quinone. So that is one of the photosynthesizers to form radicals. In the second case, benzoyl peroxide is cleaved by thermal energy, normally at 60-70 degrees Celsius. The last one is by the combination of benzoyl peroxide and tertiary amine. This combination generates radicals as a result of redox reaction at ambient temperature. Have you ever seen the dentist often use blue light during treatments? That procedure is actually for generating radicals to initiate radical polymerization in the oral cavity. The next reaction is propagation reaction. So by this reaction, polymer chains are formed. Well, an initiator radical, shown here, this is quite reactive, always looking for electrons to fill the vacant orbital. On the other hand, monomer, I show you here methyl methacrylate, MMA, as an example, which has CC double bond, that is electron-rich structure. So that is why the radical attack CC double bond to receive an electron. As a result, initiator fragment bind to the monomer. The CC double bond is cleaved. And importantly, new radicals is generated at the other end of monomer here. So this is called monomer radical. This monomer radical is also unstable, attacks another monomer. So such a reaction repeatedly occurs many times, but at once. And finally, we obtain polymer form, polymer chain made of a lot of MMA, methyl methacrylate. The final step is reactions to terminate radical-mediated polymerization. Actually, there are two types of reactions. These are similar to each other in the sense that by these reactions, radicals disappear. The first one is called recombination reaction. Two radicals at the end of different growing chains combine each other to be the stable form. There is no radical anymore after this reaction. On the other hand, in the second case, this proportionation, a radical at the growing end attacks hydrogen on another chain. As a result, there is no radical anymore after this reaction as well. Because there is no radical after these reactions, propagation cannot occur anymore. I mean, radical polymerization is terminated.
That's all about the example of my lecture on dental materials, especially this time on polymer synthesis. The contents that I gave you here were probably not very easy for you, but I hope that you had a good impression of the lecture, and hopefully you will be one of the students in a class in the future. Now I stop my talk. Thank you very much for your kind attention.